Hi, I'm Guy Harrison. This is an introduction to ProvenDB, a blockchain-enabled database service. So what is ProvenDB? As I said, ProvenDB is a blockchain-enabled database service. What it does is it integrates a MongoDB Atlas database with the Bitcoin blockchain. So why do we want to do this? What's so important about the blockchain? Well, the blockchain is a completely new type of data store. It's public in that all the transactions are visible, even though they may be anonymous. It's tamper-proof. Once a transaction's made, it cannot be altered. If it could be altered, of course, we could steal Bitcoin, so this has been demonstrated by the resilience of the Bitcoin network. It's distributed. The system is maintained by a network of computers around the world without any centralized data storage or administrator. And it has an immutable history. All of the transactions that go to the Bitcoin blockchain are preserved and none of them can be altered. Now, this immutable history is revolutionary in computer science. We used to say that history was written by the winners, but in database technology, history is written by the developer, DBA, or the application. There's no real practical way to detect backdating or tampering with data. You can say a timestamp in a database is whatever you want it to be, so therefore we can't rely on data in traditional databases. But in contrast, there's no arguing with blockchain data. Once data is sealed on the blockchain, it's immune from modification. And this feature is foundational of the blockchain and is a true revolution in computer science. Legal recognition of the immutability of the blockchain is, in terms of legal proof, is emerging. There's bills in multiple US states and in China that recognize that blockchain proofs are proof in law, and there's legislation passed or pending in a plurality of US states recognizing this, and we expect more legal recognition to come. Unfortunately, we can't use the blockchain as a traditional database because of its many drawbacks. Its performance is very poor. It has a very high latency and very low throughput. It can store only a minimal amount of data. It has no schema or data model. Transactions are visible to everyone, although they may be anonymous. The cost of each transaction is very high, and it's a very poor development environment for developers who are not familiar with the blockchain APIs and who would really prefer to use the traditional database-centric development paradigms. In particular, the economics of the blockchain rule it out for anything but the most trivial of data storage. It would literally cost you tens of millions of dollars to store gigabytes of data on either the Ethereum or the Bitcoin blockchain. So this creates a dilemma. Either we use the traditional database, in which case we can't take advantage of these important new features of immutability and tamper detection, or we use a blockchain and sacrifice performance and economics. And you can see this dilemma playing out in discussions across the internet as people are struggling to work out whether they should use a blockchain or a database. So in ProvenDB, we've tried to bridge the gap between blockchain and database in a way to solve this dilemma. So ProvenDB is a fully functional database service. It is in fact MongoDB, a MongoDB backend. It has normal throughput and latency. It supports all the rich database and query operations of MongoDB, and it has strong privacy. But it's integrated with the blockchain to provide versioning of data, immutability of data, tamper detection, point-in-time history, and a complete data provenance. So let's look at each of those features in a little bit more depth. ProvenDB differs from a normal MongoDB database in that it versions data. So new data does not overwrite old data. Instead, new versions of the data are created. An update statement does not destroy the data it's updating. It creates a new version of that data. Selected versions of the data are pinned to the blockchain and cannot be altered. Any attempt to alter any of these versions can be detected by comparing their hash with the hash of that stored on the blockchain, and we'll talk more about hashes in a minute. It allows for point-in-time history, the ability to set your view to previous points in time and view the state of the database at that time, again proved on the blockchain. And it allows you therefore to track the provenance of data items, so you can see how a data item evolved over time. So why would you use ProvenDB? In general, you'd use it to prove that you created some content for intellectual property, for instance, to prove that a document or data had not been tampered with or altered, to prove the date, which might be important for legal or official reasons, or where you want to track the complete provenance of some item in a completely provable way. And these features make ProvenDB very suitable for applications such as document management systems, legal record keeping, intellectual property and media management systems, audit and access control, accounting systems, or government and regulatory applications. So how do we manage to solve this dilemma? How technically have we bridged the world of blockchain and database? Well, the first concept that's important is that of hash signatures. So a hash signature is a sort of a mathematical signature of document, a digital fingerprint if you like. We take a document or a piece of data, we run an algorithm over it which generates a 256-bit number. And that number is unique to that document. The chance of two documents having the same hash are infinitesimally small. Even if all the computers in the world calculated hashes as fast as they could, it would still take more than the lifetime of the universe to find a duplicate. So in practice, hashes are far more precise proofs of identity than DNA or fingerprints are for human beings. Blockchain uses hashes within its internal algorithm. So each block in the blockchain contains a hash, and that hash is constructed from the transactions in that block together with the hash of the previous block. And so blocks are chained together in this way. Calculating the hash is computationally expensive. This is the basis for blockchain's revolutionary proof of work algorithm. So miners around the blockchain network are trying to calculate the hash. The first one to calculate the correct hash is rewarded with Bitcoin. So in order to recreate the blockchain, to overwrite any previous entry, it would be necessary to assemble computing power equal to all of the computing power that had been used since that block had been laid down, which in practical purposes is difficult if not impossible. But in addition to that, because of pruning and timestamping, the Bitcoin network would reject any block that came in the distant past, making it literally impossible using current technology to overwrite any previous entry. So we can use these characteristics of the blockchain to prove documents. The simplest way to do it would be to create a hash of a document and then store that hash on the blockchain. And we could use that hash to prove that the document had not been altered, and we could use it to prove the document's timestamp. However, there's two problems with this approach. Firstly, we'd need one transaction per document, and this would be expensive. A blockchain transaction costs a couple of dollars, which might be okay for one or two documents, but not okay when you're doing thousands of documents per second. Also, if we lose a document, our hash is useless. We've done nothing here to sort of preserve the link between the hash and the document. So in ProvenDB, we've solved both of these two problems. The first problem is solved by using Merkle trees. A Merkle tree is a way of proving multiple documents in a single hash. We take a bunch of documents, perhaps hundreds of thousands of them, we hash them all, and then we create hashes of the hashes and then hash those hashes and keep hashing until we've got one hash left, the root hash, and that is placed on the blockchain. Now, we don't need to use the entire Merkle tree to prove an individual document. We just need the path between that document and the root hash, and using that Merkle path we can take even an individual document and prove that it was included in that hash. So in this way we can prove hundreds of thousands of documents with a single blockchain transaction, which solves the first problem of the cost. The second problem of preserving the link between the hash and the document is solved by the application of database technology. So in ProvenDB, transactions are stored in a MongoDB database. As we add additional transactions, we create new versions of that data, and then those versions can be pinned to the blockchain, making them immutable, and using Merkle trees we're able to prove any individual document in those versions, as well as the versions themselves. So that's a brief summary of ProvenDB, technologies and concepts. I hope you found it interesting. Please sign up for a ProvenDB early adopter account at ProvenDB.com. You'll get a free 1 GB database storage system. It's a completely MongoDB compatible database service, so if you know MongoDB, you already know ProvenDB. I hope you give it a shot and let us know what you think. Thank you.